around, Jay here, and this video we're going to talk about some programming concept. Today's video is on decision structures, and that means if statements. If something is true, we do something. If it's not true, we may do nothing, we may do something else. Okay, so let's have a look at some if statements, and we're going to start very simple, and as we go down they'll get a little bit more complex. All right, I'm using replit.com today for programming in Python, and I'm new to replit. I'm learning that every time I save the file it reformats it. I've tried to put some extra spacing here so we can look at one type of if statement at a time, but it keeps removing all my extra spaces. So we'll figure it out. All right, so first one I have, let me just preface, in the beginning of each if statement I have a couple of print lines, one that's blank just because I'm going to print a blank line, and then another one where I'm going to print a description of what it is I'm doing. That way in our output we'll be able to see some output that actually makes sense, some human readable output. That's amazing, right? Okay, so first if statement, I'm going to start by saying that x is equal to 10. Doesn't really matter what I'm doing. It is, again, just an example. I'm going to say x is equal to 10. So x got some value throughout my program, and then I get to the if statement and I say if x is greater than 5, then I'm going to do this right here. Okay. And the way Python works, I have my if statement, and then at the end of it, I have a colon. I don't have to put my if statement in quotation marks, but you can use quotation marks if you like. I'm used to using quotation marks in every other programming language, but Python doesn't require them. It is definitely useful as you make more complex if statements to use parentheses to make sure that your formula, your algorithm that you use in there, whatever you want to call it, works the same way to you as it does to the computer. Okay, so use parentheses whenever you get something a little bit complex to make sure that the way you wrote it and the way the computer actually executed it are the same, because you may write something that you think works one way, but the computer is actually going to do it another way. We've all seen those silly math problems on social media. Just use parentheses and solve your problem before it even happens, okay? So we're not doing any super complex ones like that today, but if we were, we would have parentheses in there. So we have our if statement here on this line, and we end it with the colon. And then the way Python works, other languages will have us use a curly bracket to start and end our block of code that belongs to the if statement. If this evaluates to true, every next line that's indented, one indentation in, I could have multiple of them. I could have a bunch of them, right? And all these will execute, okay? And there's a keyword that we'll talk about, we'll use plenty in the future as well, called pass in Python. If you want to write part of an if statement, you want to write it, but you don't want it to actually do anything, you can use the keyword pass, and it's a piece of code that actually executes. It doesn't do anything, but Python requires you to actually have some code in every block of your if statement. You can't just put a comment in there. In other languages, I'll write a complicated if statement, and I'll write every possibility, even the ones that I don't plan on using. I'll write them so that I understand how the code works, or maybe somebody else in the future who is working on it, they understand how the code works, but it won't do anything in there. I'll just put a comment And I wrote, this is for the future. In case we need something, it's already here. In Python, you can't only put a comment in an if statement. You have to put a piece of code. And so we have this little code pass that doesn't do anything. That's kind of the same thing, but it is an extra step. All right, so this is our simple if statement. If this is true, do this. If this evaluates to not true, this won't happen. Okay, and it will just skip this part and go down below the if statement and start running more code as if that didn't happen. Okay, let's go down to our next type of if statement, which is an if else. So I have a little header right here again, setting x to a new number, x equals 3. If x is greater than 5, just like before, we'll do this. Well, today x is not greater than 5, not in this one. So else, if x is anything other than, if this is not true, we're going to go down and do this. Okay, so it doesn't matter what x is. If it's not this, we're going to do this. And we know, because it was a simple x is greater than 5, oh, x is not greater than 5. Okay, could be equal to 5, could be anything less than 5, could be negative 1,000,000,006. We don't know. We just know it's not greater than 5. Next type of if statement is, the way Python does it is a little bit different than some other languages. Other languages you could just do, well, let's talk about how Python does it first. Okay, we have x equals 5. If x is less than 5, print x is less than 5. Well, it's not less than 5, it's exactly equal to 5. So elif, which is Python for else if, x is double equal sign, doesn't mean the assignment operator, which we talked about previously. This is the is it equal to, is the left equal to the right symbol, double equal sign. Is x equal to 5? Well, yeah, because we just assigned it equal to 5, so it better be. We only just did it, right? It hasn't had a chance to change yet. So if it is equal to 5, we'll print x is equal to 5. And then we could do as many of those elifs as we wanted for all the possibilities in our giant if else, right? And then at the very end is always useful to put a trailing else if any other values are in there that you didn't account for already in these above options. If it's anything else, we'll do a final output of something, right? So it wasn't less than 5, wasn't equal to 5, so the only other option is it has to have been greater than 5. Okay, and if you have much more complicated ones, you could have, if it's this, do this. If it's this, do this. Else if it's this, do this. Else if it's this, do this. And sometimes when you have those many step if else's, if you don't write them in a way that's mutually exclusive, there's a little overlap in some of them, then the order in which you write them becomes important. So it's important to make sure that you don't have if else if statements that have overlap, because in the event that, let's say I said, if this is less than 5, do this. If this is less than 4, do this. Well, if it's less than 5, it could also be less than 4. And you're only going to ever do one of these possible things. It's going to do one, and then it's going to skip all the way to the end down here below the whole chain and carry on from there. Okay, so make sure you write these in the right way, that not one possible input could ever give you multiple outputs, because you're not going to get multiple outputs. You're only going to get one, and it's going to be the first one that happens. Computer will do that, skip to the end afterwards, and carry on with the program. All right, next method is you can put if statements inside of another if statement, right? Okay, so these are called nested if statements. We're going to nest some other stuff in the future as well. Today we're nesting an if statement. So we start by saying x is equal to 10. And then if x is greater than 5, then we jump into this inside portion. Okay. If x is less than 5 or equal to 5, we're not going to do any of this inside portion, and we're going to skip right down to the else. Okay. So this is important when you nest. It's an all or nothing. If this is true, you do all of this. And if it's not true, you do none of that. Okay. So in our case, x is 10. That's greater than 5. So we're going to do all of this. And all of this is, hey, is x less than 15? Well, yes, it is. It's 10. That means we're going to do this. And because this is another if else, we're gonna act on these appropriately, right? So we're gonna do this one, and we won't do this one because that's on the else side. Okay. This has been evaluated to be true, so we do this. Okay. Carrying on. If that was tricky, just rewind and watch it again. All right, and last, we can use, let me add some more space in here. We can use and, or, exclusive or, and not. Nope. And not. Okay, so ands and ors, think of the Venn diagram. You have two circles, they overlap a little bit. If the value is one of those values in the middle, it's an and. It's both things, right? If the value is anything in there, it's an or. It could be both, but we know it's at least one. And the exclusive or is it's not in that overlap in the middle at all, but it is only in one of the two ends. Exclusive or means this or this, but not both. And then the not, which we'll get to in a second here, that just does the opposite of whatever you put it in front. Put it in front of. And you can put that in front of greater than, less than's. You put that in front of equal to's. It's a pretty good way of writing things. Sometimes you have to write things the opposite of what it is to make it more human readable, because even though a computer is going to do this, a human has to write it, and a human has to come back in 6 months and modify it, right? You know, like the computer, the thing has to be updated. There's a bug in there somewhere in the computer, and you have to come in as a person and redo something in here. So sometimes you have to write things in more human-friendly ways. So sometimes we use the not in order to write things that are equal to, equivalent, but we just want to write them a little bit different. And we'll get to that. So first one, if x is less than 5 and y is greater than 10, x is less than 5. If x is greater than 5 and y is greater than 10, we're going to do this. Okay, well, x is 7 and y is 12. Both of those are true. So it's an and. Both of them have to be true. Okay? And most programming languages have something called a short circuit for ands and ors. In the and case, we have x is greater than 5 and y is greater than 10. If x was not greater than 5, this first part is not true. The computer does not have to evaluate the second part because it's an and. If one side is false, it knows the whole thing is going to be false. So in order to save time and efficiency, it's not going to even evaluate the second half. Okay, that's and also there's a short circuit in and. Next one is or. If x is greater than 5 or y is greater than 10. Okay, so it's the exact same thing, but it's the or. So one of them could be true or both of them could be true. It doesn't matter which one or both of them. Or is cool with any of that. As long as both of them are not negative, the entire thing in in an or will evaluate to true. So there's also a short circuit in here. If x is greater than 5, true, we don't have to check the other one. If one of them is true, that's good enough. Right? So for efficiency's sake, the computer, if the first one is true, it won't check the second one. That means it's your job in both of these cases. On the or side, if you think one of these is more likely to be true or false, then you could impart some efficiency by putting the correct one first. And what do I mean by that? In the and statement, if one of these two things, if x being greater than 5 or y being greater than 10, if one of those, you know by looking at previous data, one of those is more likely to be false, you put that one first, and then when it's false, it doesn't have to check the other side, your program becomes more efficient. If you put that one second, it's going to check the first one, true, and then check the second one, false, and then it goes through. So the more times you can get it to short circuit and not check that second one, if that's a thing. Sometimes you write a program and you're like, I have no idea which one's more common. And you just write them in whatever order makes sense for the human reading it. And unless you're really trying to cut corners on efficiency, just write it in the most logical way, regardless. All right, next one, we got the exclusive OR. In some programming language, the exclusive OR is called XOR, exclusive OR. That's how it's written up here. In Python, we're going to use this caret key. That's hold shift and press number 6. Check it out on your keyboard. You may have never written it before. This is like the OR, except only one of them is allowed to be true. If both of them are true, then the entire thing will evaluate to false. So this one's not going to short circuit. It has to check both of them every time, so you don't have to worry about efficiency and how you write it. Okay, so in this case, if x is greater than 5, exclusive or y is greater than 10, well, x is 7 and y is 12, like we saw up here. So both of these are true, which means the whole thing has to evaluate to false. And this first one, that's not going to happen. If we look at our output over here, both or neither satisfy the condition, right? So they could potentially both be false, and then exclusive OR is going to be false, or they could both be true, and then exclusive OR says, nope, this is false. So exclusive OR means they just have to be different. They can't be both true or both false. It's not used as much. There's usually a different way you can write it, possibly with nesting, okay? All right, next we have the not. Depending on where you are writing the not, it's either going to be the exclamation point or the keyword not. I have an example for each here, right? Actually, this is not equal to, which is both of those things together is one operator, one comparison operator, but you get the idea. So the keyword not means the opposite of whatever this is. So I have, and I'm using parentheses to make sure that the not doesn't just attach itself to the x alone, and the not is in reference to the entire x is less than 5 comparison. So if x is less than 5, not, we're going to do this. So if this evaluates to true, that means that x is greater than or equal to 5. And we can use this sometimes when we're evaluating things, so we can try and write them in a more human way, right? So up here I had x is greater than 5, and over here I have, let's even change this to if not x less than or equal to 5, which is the exact same output as x is greater than 5, because greater than is the opposite of not less than or equal to. Okay. And sometimes we want to write it the opposite way just so it's more human readable. So you don't have to memorize any of the opposite things. Just remember, hey, sometimes I can write the opposite of things and it might be easier to understand. Okay. You'll get used to it over time. That's kind of a thing you pick up. And then this here is if x is not equal to y, and then you know they're different, right? So that's kind of like the XOR, right? Make sure that they're different. The not equal to, make sure they're different, just in a totally different way, right? And if I run my program, this is my output that I get. Let's scroll all the way back up here. Okay, plain if statement. If x is greater than 5, print x is greater than 5. And it did, because that indeed is true. X is 10 in this case. Right? Come down to the next one, we reset x equal to 3, and then if x is greater than 5, print x is greater than 5. Nope, 3 is not greater than 5, so we put x is not greater than 5. There's that not again. Sort of. Right? In the next one, we've reset the x to 5. If x is less than 5, print x is less than 5. It's not. Else, if x is equal to 5, print x is equal to 5. That's what we printed. Scroll down to the next one. We have nested. We reset x to 10. If x is greater than 5, then do the following. If x is less than 15, print x is between 5 and 15. That is what we did, because 10 is between 5 and 15. And then way down here at the end, all of these should print something, I think, if I remember correctly here. X is 7 and y is 12. If x is greater than 5 and y is greater than 10, we're going to print both of them satisfy the conditions. We did. They both do. And we did the or if at least one of them satisfied the condition. Yes, we did. At least one of them. Okay. It doesn't tell you which one, but sometimes you don't care which one. You just need to know if one of those is true, that's good enough for me. So, and does both of them have to be true, or at least one of them is true, then it's good enough. All right, next one is the exclusive or. If this is true, exclusive or this is true, but not both. Okay, so here we have either both of those things are true or both of those things are false. We're not sure, but as long as both of them are not true, this is not the most common thing, but it is a thing. And then down here, if not, x is less than or equal to 5, which is just the kind of opposite way of writing x is greater than 5. That is indeed what it printed. And then last, if x is not equal to y, we're going to print x and y are different. All right, well, that's my super long video on all the ifs, almost all the if statements, all the ones you ever need. Okay, that's it. And thanks for watching, and I'll see you in the next one.